am gonna first just start out by going over a couple of reasons why I think data visualization should really be a part of just about all data work. And I mean, if Data Classroom as a tool has a perspective or a point of view, it is that data work should start with visualization. Um, I'm going to go through three kind of examples of this to help make my case and illustrate for you why data visualization can be so important for a variety of reasons. And number one is that there could be a dinosaur hiding in your data. My PhD advisor always said to me that he didn't want to see any numbers until he could see a data figure. So that was really an integral part of my training in learning to work with data, is that you would visualize your data first. And so we'll take a look at some data and go hunting for a dinosaur that might be hiding in there. Um, Number two, I think that graphs help you ask the right question often. I know that as a good scientist, you are not supposed to find your hypothesis in your data. But I do think that your data and a visualization of your data can be used to help you refine your questions and often lead you to new questions or new ways to ask those questions. And then number three, I think intentional graphs speak both loudly and clearly. And I'm going to talk about what I think is the difference between a graph that is speaking loud and a graph that is speaking clear. And I would endeavor to do both of those things. And if you can, train students to do both of those things as well. Um, I'm going to be using the Data Classroom tool to illustrate these concepts. That doesn't mean these are concepts that only apply to the Data Classroom tool. These are sort of perspectives that I think hold true no matter what you're using to work with your data. If you are interested in opening up Data Classroom and following along and doing some of the same playing with data that I'm doing in the same way that I'm doing it, you can scan this QR code to get 60 days of access to all features on Data Classroom. And I also want to say that we are a freemium tool, and there is a heck of a lot you can do for free on there, even when that 60-day trial is up. So with that, I'm going to actually stop my share for just a second, and I'm going to transition over to a window that has Data Classroom on it. And how did that work with the share as presenter? Did you all feel like that looked good? Okay, we're going to do that again with the little me on top of the screen there. Okay. So um, you are now looking at my Data Classroom dashboard. This is kind of the main navigation area of the web app. There's a resource library of data sets, and you can get to that by clicking on that big band of colorful tiles up at the top. But I've actually kind of prepared a data set exactly the way I want it for this presentation. So I'm just going to go down to my list of recently visited items, and I'm going to open up this version of the Datasaurus dozen here. This is a really interesting data set. We have a version of this in the resource library that a student could do as an individual. We also have a version of it that teachers could deploy with groups of students, up to 12 groups of students. So you could do this as a whole in-class activity if you wanted. I'm not going to be doing the entire activity, but I'm going to kind of tell you what the Datasaurus dozen are all about. And this is a data set that has been specifically made to illustrate why graphing and data visualization are so important. As I scroll through the data set here, this data set has 1,846 rows of data in it, and it's broken up into these subsets that are these data samples, and they are listed as A, B, C, D, etc. On here. And I'm going to go over to the graphing part of the Data Classroom tool, and we're going to start exploring these data. So I'm going to add first just this y variable and look at a visualization of this variable called y variable across all 1,846 rows of data in the data set. And you can see I've used these semi-transparent points so that you can see where the data is more dense, and those are the areas where it's darker, and where the data is less dense, and that's where it gets thin. And you can particularly see that at the two ends. But if you look carefully, you can kind of see some bands in there where data are stacked on top of one another. I could go ahead and look at the descriptive statistics for this, and I'm just checking this box over to the right, and I'm going to get the table of values for that. And we can see that the mean in this data set, which is visualized with that little blue dot off to the left, that is 47.8, and the standard deviation is 26.8. Now, an interesting thing about this data set is I'm going to look at this variable called data sample for a second, and I'm just going to pop this open so we can look, and we see we have these groups A through M here. And what I'm going to do is I'm going to exclude all of them except the M group. So I'm checking these boxes to exclude these. And there are numerous ways you can filter your data in DataClassroom. This is just a very transparent one where you can see exactly what I'm doing. So I chose to go here. And then I'm going to apply this filter. And now we're looking at just the data points for that Y variable for that M data sample group. And it's interesting that you notice that this mean hardly changed, right? I can't actually remember what it was before. Was it 47.8 exactly? It was something, it was either that or it was very close to it. And the same with the standard deviation is 26.9. So mean of 47.8, standard deviation of 26.9. I'm gonna now focus in on a different group. So instead of M, we're gonna look at L. So I excluded M and I included L. And I'm going to look at this again, and we see the mean is unchanged, right? So different group of data, same mean, same standard deviation, but they're not the same data set, right? And if we were just looking at the numbers, those descriptive statistics, we might conclude that these were exactly the same. And you also might be saying, well, they don't look that different to me right now, right? But I'm going to go ahead and add this variable called X variable. So with this particular set, right, we can see the XY plot with the X variable on X, the Y variable on Y. And we look at this, we can see the distribution right away. We see this interesting pattern where it looks like we have these bands that go kind of diagonally repeating across the screen. I'm going to add a regression line, and I'm just adding this off to the right of the graph. You'll see there's that box where I can add a regression line. And so I added a line of best fit. We can see the equation for that line. We can see that the slope is a negative 0.11, and the R squared is a 0.004 there. I'm going to go ahead and now look at a different group of data. So we were just looking at the L group. I'm going to look at the M group, and we can look at it again, and we see that the slope is almost the same. It's just slightly different. Instead of a negative 0.11, it's a negative 0.106. So very, very close to the same slope. The R squared value, 0.004, is almost identical. But when you just look at the plot with your eyes and you look at what's going on, it's a completely different set of data. It's a completely different distribution. And we wouldn't have realized that if we were just looking at parameters like the mean, the standard deviation, the R squared, the slope of the line of best fit. That was completely obscured. And each of these groups in here all have the same mean, standard deviation, slope, R squared. And there's one group in particular, this A group. When we look at this, we will see we do in fact have a dinosaur hiding in the data. And even this dinosaur, which is a clearly contrived XY plot, it has the exact same parameters. So the mean of Y is the same, the standard deviation is the same, the slope of that line of best fit, I'll bring it back, it's almost the same. It's a negative 0.103. The R squared is still a 0.004. So there's a lot about the data that you can get from a data visualization that you simply cannot get just from the numbers. So sometimes there is a dinosaur hiding in your data. Okay, for my next example, and I want to illustrate that graphs can help you ask the right questions. I'm going to leave this data set and I'm going to go to the Data Classroom resource library. This is a collection of curated data sets that have activities that go with them. There was an activity for that data source dozen. We didn't even look at the student-facing assignment, but that's in there if you think that's an interesting data set to work with. But I am going to pull up this data set that's called Early Spring in Kyoto, Cherry Tree Blossom Dates, Historical Data. So I'm going to open up this data set. And this, I want to illustrate how graphs can sometimes help you ask the right questions or help you refine your questions. This data set is really interesting. Every year since about the year 812, the Japanese have been recording the first date of full flowering. And I believe that's defined, and that's in the assignment here, but I believe that's defined when at least half of the blooms on the cherry trees are open. We're into full flowering date. And every year they simply recorded that data of when that date was. And if we look at the data for full flowering date, we can see that the overall through this whole data set encompassing hundreds of years, the average day of first flowering is day 104. And to give you some reference on that, the days are January 1st is day number 1, and December 31st would be day 365. And so you can see this day 104 is April 14th. That is the average day. And you can see we have a lot of data here, and it ranges. It looks like the latest the cherry trees have ever been in full flowering is day 128, which is May 8th. And the earliest recorded date is day 86. That's March 26th. So you can see kind of the range. And when we look at this historically over time, we can see this pattern. And this right here is interesting because if you ask students to make a hypothesis about this, they will usually or quite often hypothesize that the date of full flowering and hence the start of spring is probably moving forward due to climate change, right? This sort of matches with a lot of the science that we've heard a lot of high profile science that is very concerning to a lot of us. And if we add a regression line to this, we see that there is a slight negative slope indicating that date of full flowering is moving forward just a little bit, but it is very, very close to a flat line. And the R squared value indicates that less than 1% of the variation in flowering date is explained by the passage of time across this data set. And so this is a bit of a surprise result from what you might expect. But with our data set and with data visualization, we can explore this a little bit further. And if I add time period, and you can see I have in this control panel at the right, you can see what's on X and Y are in red, and Z controls this legend. And when I add time period as my Z variable, now we've color coded the data, and we've color coded it into these two periods, the post-industrialization, so everything from 1850 to present, and the pre-industrialization period, everything before that. And when we actually fit separate models here and we look at the slope of the change over time that's occurring, we see two very different patterns. And it is through that act of data visualization that you can get the idea to say, well, wait a second, let me just look for this specific time period. And if I actually go ahead and go back and use the exclude in much the same way that I did with the Datasaurus data set, I can look, this is what's going on in the post-industrial time period with flowering date. And we see that, at the beginning in 1850, the best prediction for first flowering date would be somewhere here around day 108. But at the end of this data set, 2021, the prediction is somewhere around day 97. So that has that date of first flowering has actually moved forward by 11 days, or the best prediction that a model could give us of first flowering date has moved forward by about 11 days since 1850. And this tells a very different story. And it's, because the first question of, how has the date of flowering changed since the year 812? That was one question, but it wasn't the most interesting question. And that question kind of pops out at you when we were looking at just that post-industrial time period. And again, I'll put all the data back up, but leave it color coded. And we can see that in the blue period, the more modern period, it's interesting to ask, wait, that looks like there's a big change there. What is that change? We can describe that with a linear regression model. And again, I think data visualization can sometimes help you pull out a more interesting question there. And again, just to, I didn't exactly do the student assignment, but those are basically the steps that a student would recreate. And that's the aha moment a student would have. This is the student-facing assignment where it gives them a little bit of background. It explains what the variables mean, and then they work through the activity and graph making there step-by-step, kind of how I did there. Okay, and so I have sort of one more story to tell here, and this is about how I think that data visualization can allow you to speak loud and clear with a graph. And I'm going to pull another data set out of the resource library. This is data from a somewhat recent experiment that was published in the scientific literature within the last decade or so. So this is fairly recent science. And oh, sorry, actually, I'm going to pull up a custom version of this because I made some changes. So let me go back to my dashboard, and I'm going to pull up this life on the edge, biodiversity in coastal habitats of Nova Scotia. And I've named it default graph because I want to use this to illustrate a point. And I'm gonna go ahead and show you this default graph, which I've pulled up here. This is a pretty typical default graph for a dot plot like this. In a lot of softwares, this would be sort of the default. I will say in DataClassroom, I had to sort of ugly up the default a little bit. I had to take away some color and make it a little bit less visually appealing. But this is a pretty standard kind of default-esque graph. And this experiment was simple. Scientists were looking at both habitats that were exposed to the full force of waves from the Atlantic Ocean, and that they defined or they called those the exposed habitats. And then sheltered habitats were habitats that were not facing the open ocean, but were on the backside of large rocks that were breaking the waves. And then scientists were measuring biodiversity in small quadrats in both of those habitats. And they were measuring the number of species there, calculating an index called species richness. And that's the data you see here. And you can draw the conclusion from this that the exposed habitats tended to have higher species richness. And there's nothing technically wrong with this graph. I think this graph is clear, but it's not loud. And so some things that I would do if I was going to make this graph speak more loudly is I would start playing with color and spacing and labels to make this a little bit more clear of a picture. So some things that I would do is I would pick some custom colors. I might do some semi-transparent points there. And then I would choose a distinctly different color for the other group. And then I would probably make it semi-transparent to match. And then that's my first change. Another change I would make, and I'm going to open up the appearance menu over here on the right, and we're gonna change a lot of things here. So one, I would make these data points bigger. There's not that much data in this experiment, and so I can make these fairly large. I have plenty of space to work with, but I can still see the points, and the semi-transparent nature, lets me see those. So I can see my points clearly. I might drop my grid lines on here because I think it's just a little busy. I might even drop the edges all the way off the points and go with this. And then I'm going to set this up to do something that is going to highlight my difference in means, which when you think about speaking loudly with a graph, you want to think about what is the main story or the main point that you're trying to get across. And the main point here is that we have a difference between these two groups, right? The exposed habitat has greater species richness than the sheltered. So I want to do something to emphasize that. And it's fine to show the raw points. I actually think that's really valuable. You can tell a little bit about the distribution. You can tell a little bit about the sample size, but adding those big chunky bars to show the average, that really hammers home that, hey, this green bar is taller than this blue bar, right? There's a difference here. Another thing I would do is I would make these labels much larger. Again, if you want people to read something, then you should make it very, very easy to read. So I'm gonna crank up my axis label size pretty large so we can see those. And then even the markers, so where the labels for the two treatments, I'm going to make those a bit larger, and maybe my numbers. The actual numbers are maybe the thing that aren't as important to make super big and super readable, because I think you want people to get the story more than you want them to get the actual values of species richness. And then the last thing I would do here is I would think about the dimensions of this graph. And if you're trying to emphasize a difference that you're illustrating in that vertical plane, the difference between the heights of those bars, I'm going to take my graph and I'm going to scrunch it up so that it's more of a rectangle shape like that. And that's the final figure. I would copy that to my clipboard, and that's the figure that's going to go, in my lab report or in my publication. And that's what I would want to show. And so kind of going back to that, in summary, I would say, don't show just the default when you could make a graph that speaks both clearly and loudly. And are you seeing my slides again? Did my screen share track over? Yeah, okay. And so, this is really close to that final graph that I produced there. But I wanted to show you again all of those things that I consciously did before my graph was ready for final sharing and final publication, right? It isn't just use the computer, have it spit out a graph. If you're communicating with data, then go ahead and communicate with data. Color and space and labels, these are the tools that you can use, and you want to be intentional with your graph. And I think there's a lot to gain as a student researcher, as a scientist, just as a kid doing your homework in math class or science class. You want to be able to communicate that point. And certainly in the world of work, there are all sorts of ways where people need to communicate with data. So this is a valuable skill for students to get. Okay, so that we went through all three of my stories there. Things could be hiding in your data. Graphs can help you ask the right question, and graphs can speak loudly and clearly. If you're interested in playing around with Data Classroom on your own, there's that QR code again for a 60-day free trial of everything on Data Classroom. And happy graphing, everyone.